Imagine a beam of light emerging from a distant universe. Traveling through space and time for over 8 billion years to finally reach Earth and cause a puzzling phenomenon. That is exactly what an international team of researchers discovered using ASKAP, a radio telescope array located at the Murchison Radio Astronomy Observatory in Australia. This event, named FCB-20220610A, has attracted scientific attention for several special reasons. FCB-20220610A not only traveled significantly farther than most recorded FCBs, but it was also extremely powerful, exceeding the maximum limit set by previous models by 3.5 times. The researchers' analysis uncovered another oddity. A measure of the spread of wavelengths, called the dispersion measure of FCB-20220610A, also did not match expectations. This has led astronomers to reconsider their hypotheses when using these phenomena as tools to study the universe. Since the first FCB was detected in 2007, scientists have only observed a few dozen events of this kind so far. This indicates that these millisecond duration radio wave bursts are a rare phenomenon. Most of them seem to occur only once, with a few cases repeating like earthquake aftershocks. According to Science Alert, FCBs could be generated by neutron stars when matter under high pressure inside them shifts, informed by their own extremely strong magnetic fields. The interacting forces involved help explain why FCBs explode with the energy of hundreds of billions of suns in the blink of an eye. However, this also sets a limit on light intensity, the limit that this latest FCB has surpassed. The brightness of FCB-20220610A was greater than models suggested, which proposed that radio bursts are created when high-speed particles from neutron star eruptions collide with surrounding winds. Besides making researchers rethink how FCBs with extraordinary energy are formed, FCB-20220610A also poses other challenges related to interpreting how its light propagates in intergalactic space. In a vacuum, light travels at the fastest speed. However, this speed changes when it passes through electromagnetic fields, where different light wavelengths interact with this field in different ways. This is similar to the rainbow phenomenon after rain, where a spectrum of wavelengths is separated by transparent raindrops. Similarly, gas and dust floating in the vacuum between stars and galaxies carry their own faint electromagnetic waves, causing wavelengths to slow down at different rates when passing through. A few years ago, Australian researchers proposed that the light emitted from FCBs could be used to measure the spatial fog caused by matter floating between the Milky Way and neighboring galaxies, hoping to determine the density of hidden matter and the expansion rate of the universe. There is a measure of dispersion that increases with distance called the McQuart relation. This relation holds true for most FCBs within a few billion light-years. However, FCB-20220610A breaks the McQuart relation, clearly indicating that its dispersion is somewhat more complex than others. After thoroughly analyzing other characteristics of the light, researchers hypothesized that a cosmic storm of magnetic plasma between the Milky Way and the host galaxy of FCB-20220610A disturbed its spectrum. FCBs are becoming an extremely powerful tool in astronomy, literally illuminating the hidden parts of the universe. With each surprising discovery about FCBs, we understand this phenomenon more clearly. These discoveries not only help us better understand the universe but also open new prospects in searching for and uncovering unrevealed mysteries. A deeper understanding of FCBs could lead to significant advances in astronomy. From learning about their origins to using them as tools to study the universe. The telescope detected a large explosion between galaxies, and astronomers still cannot explain it. In the vast universe, a scene unfolds that astonishes astronomers. An extremely rare and strange cosmic explosion occurred, producing a strange flash of light in the space between two galaxies more than 3 billion light-years apart. And astronomers still cannot explain what it is. This explosion produced one of the brightest blue flashes in the universe that lasted only a few days. This is the latest example of a rare, short-lived astronomical event,
called a fast blue optical transient or LFBOT.
According to Space.com, LFBOT remains a major mystery. But how? This event occurred in a spiral arm of a galaxy 200 billion light-years away from us. It was 100 times brighter than a typical supernova and also bright in radio waves, ultraviolet, and X-rays.
If it were a supernova, its behavior was very peculiar.
Normally, supernovae remain bright for weeks, even months, and have recognizable spectral features. However, AT2018 POW faded after just a few days. After the 2018 brightening, scientists continued to discover similar brightenings at a rate of about 1 per year.
And they also nicknamed them after animal species.
The sparrow. After discovering the sparrow, scientists conducted a series of planned observations using ground-based and space telescopes.
The Gemini South Telescope in Chile measured the sparrow's spectrum and found its temperature to be 20,000 degrees Celsius.
This temperature is very hot, but certainly not as hot as a supernova. Infrared redshift measurements show that the Finch is about 3 billion light-years away from us.
A vast distance that only the Hubble Space Telescope could observe the host galaxy of the Finch. And when observed with Hubble, astronomers obtained an astonishing result.
The Finch is not located in any galaxy at all.
All previously observed LFBOTs were located in the spiral arms of galaxies.
But the Finch is in intergalactic space, about 50,000 light-years from a large spiral galaxy and 15,000 light-years from a small galaxy.
The location of the Finch seems to rule out the possibility that it is a supernova, i.e.,
an exploding giant star. Although there are rogue stars ejected from galaxies into intergalactic space after colliding with a supermassive black hole, giant stars only exist for about 7 million years before becoming supernovae, not enough time for them to reach a location like the Finch.
Ashley Trance, a researcher at the European Space Agency and lead author of a new paper describing the Finch, shared that.
To explain the unusual location of the Finch, we are considering the possibility that it is the explosion of an extremely fast-moving star, or perhaps it is the result of a longer process like a merger of two neutron stars that have orbited each other for billions of years, although these are just speculations.
The Finch may have challenged current theories about the nature of LFBOTs. But in science, it is often the unexpected results that reveal gaps in our knowledge and lead to progress in understanding the universe.
Additionally, the Finch could be a kilonova, i.e., an explosion caused by the collision of two neutron stars, or sometimes between a neutron star and a black hole.
This discovery raises more questions than answers, and more research is needed to find the correct explanation among the many possibilities.